So, today we're gonna talk about the productivity improvement of flexible printed circuit at bracket process. For the cause of problem in production industry for today is high competition. So, the manufacturer need to separate the market share and reduce cost of or improve the work process. For this study case, we can see the customer demand of production is normally at 600K and 800K price per day, but in November is 1.2 million per day price per day. So the manufacturer need to increase the product from improving the production process by adjust the product A. And the next table is takt time of product A. Time to produce is 68,400 and demand is 24,000. Takt time is 2.85. So the process of production are three processes. First, SMT MOT. This the process to put component to FPZ. Second, SMT Backend is the last production step, and the last process is FI is the last process of checking. And this table show you about the amount of worker and machine in each of workstation. The object of this research. The object of this research is to improve the production line and bracket of product A by using the ECIS process instead of people in some work part. At the same slide is research process. Research process have five process. First process is study the production A process of production. Second, explore the current information of work process. Third, use the information to assist in the analysis for increase the product. And four, decide the work process by current information. And the last one, make the conclusion and suggestion. This slide show your operation plan. From the table, we can see the which month we will start the process in order to know the scope of work.
Okay, chapter 2. I talk about concept and theory. We use ECRS technique to increase the product. ECRS have eliminate. Eliminate is cut off the factor that unnecessary. Combine. Combine the process that are similar together. Relays. Relays is sort the process and improve the remaining problem. Simplify. We apply specify technology to make process easier. Seven ways Seven ways are overproduction, inventory, transportation, movement, unnecessary processing, wetting, and defect. Next, line balancing. Line balancing is balance the time for a station. If it's not equal, we choose the most time. Step of line balancing: start with outline your workstation, frequency, and draw precedence diagram. Estimate the neat cycle time of each workstation. Calculate the hypothesis number of workstations you will need, and assigning take to the workstation until the progress time are equal. And the last one, take the frequency of your assembly line. Improvement guidelines are second time, bottleneck, and production line not balance. Second time is repeat the process, make the start and the end the same point. And bottleneck is a point of progression that slow the work process. The last one, production line not balanced, is the work time in each of station is not equal. That make the slow station have too much overload of work. Okay, work and time study. Work and time study. I will research motion and time study. Object of time study. Time study we interest new work, change material, work have a complaint, bottleneck, and employee and machine have overfeed time. Last one, direct time study. First, we have to choose the specified employee as less for 4 weeks and split the work rabo machine for the resource process. The last is time counting. Time counting have continuous time and snapback timing or repetitive timing. Pocket analysis. Pocket analysis are outline process chart that show in the picture, and man and machine chart. Man and machine chart is show the relay of work and machine. You can call chart is cycle time. The last one, concept and theory, is analyze of possibility. Analyze of possibility have payback period, net present value, internal rate of return, and benefits per cost ratio.
In back-end process, start with piercing. Is a cut and deal sum of sheet product. Employee put sheet one at a time into machine, then move to manual laminate on board process. Employee mount a sheet on board before put in. After that, move to laminate, adhesive, and barcode process. There are two types of adhesive, PSA and TSA, and also glue the barcode in this process. Continue with heat press to glue a TSA by heat and air press to glue a PSA by pressure. Then scan the barcode to count the sheet product. Then take off the product on board manually and send to die cut to separate each product, and finally end with inspection. In production process, we target to balance the production line, so we collect the standard time for each station. In backend process, as you see in this slide. And also this table. This table shows amount of employee per shift and a machine in each station. Time study for each process. We use this formula to calculate amount of wanted time collect at 95% confidence and 5% error. For this equation, standard time equal to normal time plus allowance time. The normal time for a particular employee is rating against the average job element time. So the normal time is equal to average element time multiplied by performance rate. Therefore, at we collecting, employee work faster than normal 5%, so the performance is equal to 105%. The allowance time is equal to personal 4%, stress 3%, and waiting 5%. For all is equal to 12%. From the formula, here are example of station 1. By calculating amount of collecting time, that confident enough to calculate a standard time or not. For other session, we have calculate at the same page. So here are the standard time for every each minor station as you see in this table. And also this table. Finally, we have a standard time in every process. It's a 21.77 seconds per each. For this table, there are standard time. So breaking process is most using time, and a second time of this process, this product is 3.03 seconds per piece. In this factory, the employee work 9.5 hours per shift and production line working 19 hours per day, and average product needed is 23,000 pieces per day. So we calculate the takt time by working hour per day divided by average product needed per day. That's equal to 2.85 seconds per piece.
3.3 Analysis productivity before improvement. We use using the three formula to analyze the productivity before we improvement. First one is the productivity formula, and the second one is utilization, and the last one is effective. To analyze the productivity, we solving labor productivity by using this formula. The productivity equal product per day divided by productivity time per person multiply labor per day. The second one is utilization. We solving labor productivity by using utilization equals standard time multiplied by amount of product divided by all used time and multiplied by 100. The last one is process effective. Effective equals sum of work standard time divided by amount of session multiplied by the second time and multiplied by 100. This table showing the effective per main station. The first station is piecing station. The standard time is around 2.56 and effective percent are 84%. And the last one and the station is banking station. The standard time is 3.03 seconds per piece and effective is 100%, and average effective of all stations are around 79.81%. In the improvement process, we analyze the production line to adjust and improve balance in production line by using ECRS and using automation to fulfill the amount of worker. Next, from the station 1, the piecing and manual laminate on board station. Before adjust the machine, after the machine drill the sheet, product worker will move the sheet by tray to go to the next station 2. And in station 2, the worker will put the sheet in the board. After we adjust in the station 1, we putting the slide rail for the output and the design base that can fit a product, or we can call it a magazine. Then we adding the auto loader to that can load it, a magazine to in a process that can help eliminate the station 2. In station 8, this station using the most time and the highest stack time. Before we adjust, the sheet will be cut by the machine. Then the worker will take the product from output by using the tray that lead to the next step. After we adding the auto load and auto unload. It can help us decrease the man time using and can help less production time and using less worker.
For the chapter 4, the result of the experiment, we have two parts to analysis. The first is the analysis of production line after improvement, and second, the analysis of cost. For the first one, the analysis of production line after the improvement. At station 1 and station 2, we add more slide rail at the output side and redesign the base to add the sheet product on board. And then we combine these stations together to reduce the process that's used in work. And at station 8, we add more auto loads and auto unload to the machine for reduce the time that's used in work too. And for the time study part, before the improvement, we use 22.77 seconds for one product. But after the improvement, we use just 20.91 seconds for one piece. And we reduce people from 12 people per one day to just 8 people per one day as well. And this slide show you about the takt time and the cycle time. As you can see, cycle time is less than takt time. That means you can produce in one day much more the target you want. And for the utilization, before the improvement, we have 27.61% of machine and 50.53 for worker. And after the improvement, the machine is 87.51% and the worker is 74.79%. And as you can see in this slide, we can increase 40% of the effective from 79.81% to 93.68. For the second part, the analysis of cost, for this experiment, we used 400,000 baht to improve the work process. And from we can combine station 1 and station 2 together. That make we can reduce the man hour about 800 hours per month per production line. So we can save about 54 baht per month. And from we increase the capability of the process It make we can produce more 2,000 pieces of product in one day. It's effective. We can make more 2.2 million baht per month of profit, but we can get payback in just 0.19 months. It's very short time.
Okay, here we come to chapter 5. In this chapter, we will talk about the conclusions and recommendations. The purpose of this research is to improve the production line of the product A by using autonomous machines instead of human in some part by the workstation. Okay, we're going to talk about the conclusion first. As we know that the product A's production time needs to be 2.85 seconds per piece, but the blanking stations is 3.03 seconds per piece. So the factory cannot produce this product according to the demand. And this paper aims to improve the production line using the EC or S technique and replace human forces by machines as the following. The first and the second station, we added a slide rail at the output side and designed the new base for passing the product to the next station. This method is combining the similar work together. For this, the air station, we added the autoload and unload port to decrease the work time and let the worker in the previous station, which is 7, load the product into the machine. After the improvement, we can summarize the standard time before and after in this table. We found that the time after the improvement is lower than the take time. So, this production line is capable of meeting the needs of customers. Let's have a look at this table. You can see that everything is numbered, right? But never mind, I'll submit that for you. The thing is, we reduced the main station, also workers. Meanwhile, our productivity is increased. It means we now produce more than we ever, and we use the machines and the workers more effectively. Okay, for the recommendations. At first, there was a little problem from the workers. They still have some problem about misunderstanding and holding to the former way with the work. So, the researcher has two recommendations. First, we should run this operation based on the workers' convenience, or they just have chance to say that about the improvement because they have experience and this improvement affect them directly. So we can use the information for more efficiency in this improvement. And second, we should use the principle of this improvement in others production lines that are similar to. For example, the machine in the first station is the same as the eighth, so we could improve some part of them using the same theory. And that's all about our presentation. We hope you enjoy, and thank you for your attention.